Hey guys, let's review. Speed and acceleration describe an object in motion. Last week you learned the speed and acceleration formulas. You learned that the units for speed are meters per second and the units for acceleration are meters per second squared. Also remember that acceleration values can be positive or negative depending on if you're speeding up or slowing down. Oh, hey there. Sitting out here in the sunshine, enjoying the beautiful day. My dog Molly. Oh, okay, thanks, Molly. Now, I was thinking about last week, we talked about speed and acceleration. Remember, those relate to objects in motion. We can calculate speed by doing d over t. Remember, that's distance divided by time. And the units for speed, meters per second, or maybe you'll see miles per hour, feet per second, lots of different things, kilometers per hour. All right, so speed, pretty easy, just the distance over time. Of course, we could also talk about changing the speed. We can increase our speed or decrease our speed. What do we call that? That's right, acceleration. So we know that acceleration is equal to what? Change in velocity over time. Or delta V over T. Remember that triangle delta means change in velocity over time. You could also see it written like this. VF minus VI over T, where it's velocity final minus velocity initial over time. Remember, velocity is another way to describe speed. It just also tells us the direction, like north, south, east, or, that's right, west. Okay, so I was just sitting out here and I thought, what if I could calculate my speed as I travel to my purple flowers? Well, I have my handy dandy meter stick. It's 1 meter, which is 100 centimeters. And to my purple flowers, it's about 10 meters. So this will help me calculate the distance. But what do I need to use to calculate my time? Aha, a stopwatch. Or my handy dandy phone, right? It's 2020, so all right. So I'm gonna time myself as I travel to the purple flowers and back. I'm gonna calculate my speed. I can walk there, I could run, I could hop, I could skip. What should I do? I'll just do a simple walk. Okay, ready? I get my timer. On your mark. Get set. Go. Whew, okay. 12 seconds. Okay, so it took me 12 seconds to travel how far? Right, 10 meters. So I know that my time was 12 seconds. My distance was 10 meters. So what was my speed? Well, I would just say 10 divided by 12. And that would give me my answer. 5/6. All right, now that we've calculated my speed, let's look at a graphical representation of the speed. Notice on the graph we've got our tidal speed, and then on the y-axis we plot our distance, 0 meters all the way up to 10 meters, or however big my range might be, and then time is always going to go on the x-axis. It's our independent variable. All right, so here you see a positive sloped line. It's a linear line, a linear slope, showing a constant speed. Let's talk about gravity. The acceleration rate of gravity on Earth is 9.8 meters per second squared. So that means objects in free fall, or objects in free fall, due to acceleration, the object will accelerate at 9.8 meters per second every second. So for example, if this expo marker falls towards the Earth, after 1 second, it travels 9.8 meters per second. After 2 seconds, that acceleration rate doubles to 19.6 meters per second. After 3 seconds, it triples to almost 30 meters per second. After 4 seconds, the acceleration quadruples to almost 40 meters per second. So you can see that if I stand on a small block and jump off, the force of my body landing will not be that great because the acceleration due to gravity did not build up. But if I go up 30 feet and jump down while I'm in free fall, my acceleration rate increases every second. Splat! The force is very great because the acceleration rate increases with every second during free fall. Pretty neat. So that's a number you need to know. The acceleration due to gravity is 9.8 meters per second squared. In other words, an object in free fall will accelerate 9.8 meters per second every second until terminal velocity is reached. And terminal velocity is all about that wind and that air resistance. Eventually, you're going to get enough air resistance that the acceleration rate will slow down and you'll begin to kind of slow down a bit. Terminal velocity. Look it up. Quick review. The acceleration due to gravity is 9.8 meters per second squared. Remember, an object in free fall due to acceleration will accelerate 9.8 meters per second every second. Here's an illustration to show free fall due to gravity. Notice that the boy is dropping a stone from the hill, and the stone accelerates 9.8 meters per second every second. Here's another graph of motion. Notice that velocity is on the y-axis and time is on the x-axis. The blue lines represent acceleration, and notice that the red line represents just a steady speed. It's not accelerating or decelerating, it's going at a constant speed. The green line is showing a decreasing slope. Since the slope is decreasing, that tells me that the velocity is decreasing as well. It's slowing down. Therefore, the slope of the line is negative. Okay, here's one more example of a motion graph. It says, describe the motion of the object for segments A and C on the graph above. Well, if we look at segment A, we see that it's an increasing slope. The y-axis shows the distance in meters and the time in seconds. So segment A shows us that the object is increasing speed or speeding up. Now look at segment C. Segment C shows a flat horizontal line. Notice that time is passing, but the distance does not change. So that means that the object in line C is not moving. It's just sitting still. Time is passing, but the distance does not change. And then again, it's going to start moving as it goes back to the original position. So when you're looking at motion graphs, it's very important that you look at the x and y axis so that you can see what your variables are. And let's review distance time graph. The steeper the slope, the faster the object in motion. And remember, if you have a flat line, horizontal line, that means that your object is stationary or that it's not moving. And this is only for a distance time graph showing speed. The last example today, we've got the speed versus time graph. If you have an increased sloped line here, you've got a steady acceleration. It's accelerating at a constant speed. If you have a flat horizontal line on a speed versus time graph, that's just showing that you have a constant speed. And then a negative sloped line will show deceleration or slowing down. Notice that value for acceleration would be negative. So that's about it. If you have any questions or concerns, be sure to send an email to me or your other science teacher. Have a great day.